Yes, welcome back to the command zone. Today's mission is to conquer the LeetCode 322 coin change problem. So together we'll be building the intuition, understand the dynamic programming approach, and perform a complete trial run, analyze the complexity, and finally implement the optimal Java solution. So before getting started, I will be informing you the techniques to solve LeetCode question. While you solve any LeetCode question, you must remember this 5C principle. 5C principle. So the principle 5C stands for comprehension. That means whenever we are in LeetCode, first we'll be understanding the comprehension. Second, constraints. We'll be observing the constraint. We'll be observing the constraint. So let's notice the constraint here. Here the constraint is 1 up to 2. That means coins.length is within 2. So this is the constraint. Let's write the constraint. 1 is less than equals to coins.length. Coins.length less than equals to 12. So this is the constraint. First comprehension, second constraint, third that is case simulation. That means we'll be understanding each cases. Before solving any LeetCode question, what we need to do? We need to understand the case. Example 1, example 2, example 3. So we need to understand the cases. So we'll be simulating the cases. Then construction of connections. That means after analyzing the cases, we'll be building the connections between this comprehension and the cases, the connection between them, the pattern between them will be figuring out, and at the end we'll be crafting the code. So this is code crafting at the 5C formula. So let's start with comprehension. Let's study what the question tells. So first of all, the question tells you are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. That means they're telling that we have coins array as we can see in the question. So let's write the coins array. This is coins array. We are given coins array, different denomination, that is the number of the value of coin. Like coin can be 1, 2, 5. So this is, so the coins array is 1, 2, 5 with the different denominations. And an integer amount representing a total amount of money. And the amount is simply 11. Amount that is equals to 11. This amount is telling us the value of money that is to us. Amount of money. Return the fewest number of coins that you need to make up to that amount. Now notice they have italicized this one, that return the fewest number of coins. Fewest number of coins. That means fewest minimum number of coins. So this is the point to note, that what we have to return the fewest number of coin, the fewest number of coins, the fewest number of coins. We have to return the fewest number of coins required to make that amount, which is required to make this amount. So this is okay. I didn't notice that we are actually getting cut. So first understand the problem, then okay, return. So I'm bringing the remaining portion in the bottom so we can see. So this is return the fewest amount 11, number of amount required to make. So this is our goal. So in the question we can see that what the question tells, that return the fewest number of coins, that we have to return the fewest number of coins. So this is our main objective. And in the dynamic programming problems, what we do, we always represent the dynamic programming dp value with this objective, that what the question asks from us, what is the objective. So here the objective is we have to return the minimum number of coins. So dp of I, now we'll be defining dp of I here. dp of I equals to nothing but this line, return the fewest number of coins that we need to make up this amount, the amount. Now if the amount of money cannot be made by any combination, suppose we are not able to make that amount of money, so we'll be returning -1. You may assume that you have an infinite number of coins. So the question tells us that we can assume that we have infinite number of coins. So this is the problem. Now let's understand the problem in detail. So this is where we are, and we'll be understanding the problem in detail. This is our 5C and this is our coins. So after the comprehension, let's understand the problem constraints. So we are provided with coins array like this. We are provided with coins array like this, 1 to 5. Coins array 1 to 5. 1, 2, 5. We are provided with coins array 1 to 5, and then with amount 11, and our goal is that we have to form this 11. So we have to think that how we can form this amount 11. How can we form this 11? So simply what happens in dynamic programming, that we try in dp we try to form the values from lower to upper, so if you notice in a DP language, this is bottom up. That is, we start from the bottom and we move towards up. That means what is bottom? Bottom is nothing but the base value. Base value. That means we'll be constructing the 11 with the value of 0. So to reach up to 11, to reach up to the destination 11, we'll be starting with 0. First 0, then 1, then 2, then 3, then 4, then 5, then 6, 7, 8, 9, 10, 11, 12. So this is our, because we are simulating the first case. We are simulating, let's notice, we are simulating this first case, coins 1 to 5, amount 11. So let's again move to the board, that coins 1 to 5, and this is amount 11. So now we'll be checking that how we can form this 11. How can we form this 11 with those denominations of 1 to 5? So first we'll be start building with 0. So in terms of language, in terms of programming, what we will try to do, first of all, to build this entire system, we'll be taking one dynamic array. So this is our DP array. We'll be initializing the DP array with, because we need to store 11 and our system start always from 0. So how many numbers we need? 11 plus 0. That means we need 12. So we'll be initializing our DP table with DP of whatever the currency value plus 1. So we'll be initializing the DP. Now we need to update the DP value one by one. So in the next step, we'll be initializing the DP with infinity value. We'll be initializing the DP with infinity value. So first of all, the initialization will be like this. With infinity, we'll be initializing this one with infinity, 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 infinity. So initially all value will be infinity. Then we'll be updating the base value, because this is 0 state. So first we update this state. So when we update this state, it becomes 0. Then we start exploring from here. That means we start exploring from here. So once we have worked for the rupees 0, then we work for the rupees 1. Then we build for rupees 2. Then we build for rupees 3. Then we build for rupees 4. Then we build for rupees 5. So let's start exploring 3. When we try to build for the currency 3, we have the denominations. Let's notice. We have only the coins 1 to 5. That means if you want to build, suppose a number 3 also, we want to build number 3. So how many possible combinations to build 3? One combination of building 3 is 1 plus 1 plus 1. That is one combination. Let's move to the board. You will understand better. Now suppose we want to build 3. So how? We are segregating. The one way to build 3 with 1, 2, 3. 1, 1, 2, 5. This is the total number of coins we can use from here. So one way is we are using one coin, 1 plus 1 plus 1. So that is a coin. Another way we can use, that is 1 plus 2. That is a coin. And there is no other way. So this quantity is becoming 3 and this quantity is becoming 2. So among them, what we have to take? We have to take the most minimum one. From here, we have to take the most minimum one. So we'll be taking this 2. That means what? We are taking this to minimum 1 and then this minimum becomes the DP. So we'll be initiating the DP value, DP of I with minimum of this and minimum of the previous value DP of I or the current value. This is DP of I or the, and if we suppose include this number 2, so this is, we are using this coin 2. This is our current coin. So we'll be subtracting that value from here, that DP of I minus coin, and then we will be adding the number of plus 1, that we are currently using 1 coin. Okay, and now this will automatically update the system one by one. First it will be 0, then the construction of 1 will be like this. There is only one way to build 1, so we'll be filling with 1. Then we'll be looking for 2. There is 2 ways to build 2, that is by directly taking 2 and 1 plus 1. What we want to minimize? We want to minimize the number of coins we have taken. So here we notice, here we have used 1 coin, here we have used 2 coins. So we'll be giving this one the highest priority. So we'll be updating this value. So this is how one by one we'll be filling the value. So let's look at the programming board, then you will understand better. This is my first video after a long time in programming. So maybe I'm not able to understand comfortably. Keep watching, and if you have any problem, let me know. So let's look at the programming. So right now we are in the programming board, public integer coin change. So what the question tells that you are given an integer array coins, return the fewest number of coins. So we always have to return the fewest number of coins. So in this problem, first of all, we need to define the dp of x. So we'll be working on the dp value. So integer array dp, that is equals to new integer amount plus 1, because we have to store the amount. We have to store the amount, and the value we want to store is from 0 up to the amount. So we take amount plus 1, integer array dp. Now we initialize the dp with infinity unreachable value. So it's like arrays dot fill dp comma, we can make amount plus 1. We can make it amount plus 1 because amount plus 1. So this is amount plus 1. Amount plus 1 is also acting as an infinity value here. Here our amount plus 1, the amount plus 1 is acting as an infinity value. Because this amount plus 1 cannot be reached, infinity value. Okay. So now we have to define the base case, that is dp of 0, that is equals to 0. Because the way to make 0 is taking only 0 coins. So this is dp of 0 equals to 0. dp of 0. Okay, now we want to build the current amount. For integer current amount, that is equals to 1. Current amount less than, for integer current amount equals to 1. Current amount less than equals to amount. Okay, for integer current amount equals to 1. Current amount. So now we check our coins. So now we start performing for our coins, that is for integer coin in coins. So we check if our coin value is less or not. So if coin less than equals to current amount, that means this coin can perform to update the value of the current amount. So dp of current amount becomes, that is math.minimum dp of current amount or dp of current amount. Now we are using the previous value minus coin plus 1. So at the end we'll be return if dp of current amount is greater than amount, then we return minus 1. Else we return the dp of current amount. Something wrong we got, cannot find symbol dp of current amount. Return dp of current amount. So this is not actually current amount, this is amount. We cannot use current amount there. Then we use current amount. Finally, our program has been submitted. So let's analyze the time complexity here. Why wasting space? So if you notice here, this is the number of coins. So if you take the number of coins C, so we are using one array, so this is C, and this is we are using another for loop. So this is actually n square. If you take in terms of n cross n, that is n square, that is. And the space complexity, we are using only one array, so the space complexity is just a big of n. So okay, that's all. We are meeting in the next video. I think I will be able to improve the quality of the video in the next session.